Hey guys, welcome back to my channel. I am Saummya and today we will be moving forward to a very important question, which is to find the largest contiguous sub-array in a given array in our Babbar's 450 questions DSA sheet. So people, this is the Babbar's DSA sheet and today we will be solving this question, find largest contiguous sub-array. This is a very important question, people. It was very first asked in Google interviews, and after that many companies are asking this algorithm to people, which is Kadane's algorithm. So let's read the question first. Given an array of n integers, we need to find the contiguous subarray containing at least one number which has maximum sum and return its sum. Let's see this array. Here it is given as 1, 2, 3, minus 2 and 5 and output is 9. Okay, so let's try to understand the Kadane's algorithm first, then we will be coding. So people, as our question says, we need to find the maximum sum subarray in our given array. Okay, so for further explanation I am using this array. Okay, and what we need to find is what is the maximum sum we can get using any subarray. So people, if we are having n elements in a given array, then the number of subarrays will be n square, which means we can check all the n square subarrays and check their sum and check for the maximum sum we are getting and return the value. But this will be a very long process and very hectic one, since for now we are having only 6 elements, but if the array may be having 20 elements, 25 elements, then it will not be practical. Okay, so let's move forward with a more better approach for this problem. So we are using Kadane's algorithm. So moving forward to our algorithm, we have taken two variables. First is the current sum, which we have given the value 0, and second is maximum sum so far. Okay, for this we have given the first element, which is 1 here. Okay, we might also have given some minimum value like negative of 99999 or int min. But since in the question we are asked that we need to have at least one element, so we are giving this first element. Okay, so moving forward, in this complete algorithm will be done in 3 steps, means there will be mainly 3 processes we need to do. The current sum will be increasing like this. Current sum will be increasing with first element is 0 like this. First it is 0, then we will be adding one element each time. Like first we will be adding array of 0 index, which is 1, then the current sum will be 0 plus 1 is 1. Again we will be adding second index 2, now the value is 1, then 1 plus 2, that will be equal to 3, and so on. Okay, maximum sum so far, it will be updated like this: maximum of its initial value, like array of 0 it is, and after that it will be compared with the current sum value. Okay, so like this maximum so far value will be updated. And one thing, since we are looking for the maximum sum, okay, then if the value of current sum goes negative, it will be updated to 0. Okay, since we want the maximum, there is no meaning of going to negative values. So let's move forward. See what we are doing. Our value for current sum is 0, as we discussed in the previous slide. Okay, and the value of maximum so far is element at 0 index, which is 1 here. Okay, now we are calculating current sum. Moving forward to next step. Current sum is 0, which is an initial value, plus array of 0, means 0 index, this is 1, and maximum so far will be updated like this. It will be maximum of its initial value and current sum value. Okay, which is maximum of 1 and 1, it will be 1 only. Okay, now moving forward, again we will check. Current sum will be updated like this: its initial value plus the next element, this is 2. Okay, the current sum value is 3, and maximum so far will be comparing its initial value, which is 1, and the value of current sum, which is 3. So the maximum so far will be updated by 3. Okay, similarly we can see again current sum, it was 3, so we will be again it will be updated like 3 plus the next element 3, it is 6, and maximum so far will be comparing the initial value and the current sum value, this is 6. And similarly all the steps will be done. In the next step, what we'll be doing, current sum's initial value is 6, again next element array of 3, means the element at index 3 is minus 2. Okay, so now the current sum value is 4. Okay, now in max so far we will be comparing maximum's its initial value which is 6 and current sum's value which is 4. Now maximum so far is 6 only. Okay, similarly after all the steps we are getting current sum as 10 and maximum so far is also 10. And people, and this maximum so far value which we are getting is our answer. This 10 is our answer. Okay. Okay people, so let's now code for this. This is our question and let's just start the code. I'm zooming it for you. So for very first we are taking our current sum as 0 and maximum so far as the first element of our array. Okay, then now what we will be doing, we will be just running a loop 0 to last element. Okay, current sum will be calculated as array index I, and at every step I'll just copy from here, maximum so far will be updated by the maximum of max so far value and the current sum value. Okay, so we'll just copy this and there was one condition, if you remember, if this current sum value is negative we need to update this by 0. Okay, now we just simply need to return this maximum so far value. Let's try to run this. Yes, we are getting the expected output, in the submit. So it's running perfectly. And one thing to note here is, people, tell me, pause the video and tell me in the comment section what is the time complexity of this code. I hope you are done. So the time complexity is of order n. If for the same question, if we were using the approach like taking all the subarrays, taking their sum and then comparing the maximum sum, in that case time complexity would have been order of n square. Okay, so that's all for today guys. I'll be attaching the Babbar's DSA sheet and our today's solution in the description, and also this Kadane's algorithm explanation if you need. I'll be providing the link in the description. So that's all for today guys. If you like my video, please like, subscribe and share my channel, and please hit the bell icon. Thank you.